Welcome. If AI terms feel messy, today we'll clean it up. By the end of this session, you will speak AI with confidence and you will know where it drives ROI in your business. This is Agentic Lab. Let's get started. Here's the plan for this session. We will build a shared language. We're going to cut jargon. We'll translate concepts into the business value. I'll leave you confident to challenge vendors, brief your team, and spot the quick wins. AI term is an umbrella. It's the systems that act intelligently. Now, machine learning sits inside AI and it learns from data. LLMs themselves, or large language models, just one specialized type. They work with language and they're trained on a vast amount of knowledge. Knowing the difference helps you pick the right tool for each job and understand terms accurately. It's important to note artificial intelligence has been around for a while and it encompasses lots of different things. When you drive onto a motorway or in a car park, that camera reads your car number plate. That is artificial intelligence in action. And those been around way longer than ChatGPT or OpenAI. Machine learning, while it sounds complicated, it's just a set of algorithms that uncover patterns in the data with a minimal supervision. That's the essence of machine learning. Generative AI, or GenAI, a term that's being thrown around a lot, is a subset of artificial intelligence that's designed to generate new items and new objects. LLM fall within GenAI, but not all GenAI using LLM. To give you an example, a lot of AI out there generates music, generates pictures, videos. Those are examples of GenAI that are not necessarily using LLM, but they're often integrated with LLM to be able to take your prompt of designing a funny cat video and translating it into instructions for the GenAI to actually create a video. Knowing and understanding these terms matters greatly for you because each subset used in the business differently based on the purpose, based on technology, vendors, and what kind of industry you are in. Arthur Samuel said it best: giving computers the ability to learn without being explicitly programmed. That's the essence of machine learning. And look at the date. That's been said in 1959. Just tells you how long this thing's been around. AI systems, they can sense, reason, act, and adapt. We will unpack each of them later. And what does it mean for the business? It means that now you can have faster decisions, fewer repetitive tasks, and a better customer service with a stronger forecast. The business is routinely in some of these areas, like a decision support or process automation, can reach 70 or 80% productivity boost by automating mundane, repeatable tasks. With that in mind, if you pause the video for a minute and think about where do you normally encounter AI? Think about the financial services, premium insurance quotes, like I mentioned, car number plate recognition, any kind of voice recognition if you ever used any type of dictation software. All of that are examples of AI. Can you think of examples where you might be already using it within your business? AI shows up in your daily life in many ways. Email summaries, auto-routing your support ticket, meeting notes, even your Google Maps is a form of AI. Amazon recommendations, another form of AI. Now, quick AI capabilities in action, and let's talk about where it often fails. On this example on the right, you can see I ask 3 different models: O3 Mini, Claude 375, and a Grok 2. I asked them 9.11 and 9.9. Which one is larger? Now you could see how 3 different models, they did all those 4 capabilities we talked about. They sensed the question that I asked them. They reasoned, they provided full step-by-step reasoning, and they acted. They responded back to me, which is a way of acting. And they learned from experience because of the interaction with me and some of the past interactions. Now you will notice that the Claude 3.7 confidently, with the full reasoning, argued that 9.11 is actually bigger than 9.9. So yes, AI is intelligent, but it's what's called a rugged edge of intelligence, where it has some capabilities that are on par or even better than some people, and yet in other instances, it can fail badly. And the reason behind that is the nature of technology, the nature of LLMs themselves. Just to contrast and compare, If AI is artificial intelligence, let's talk about human intelligence. Humans win at ambiguity, creativity, ethics, and relationships. This is where we're still far superior to artificial intelligence. And in many cases, the best solution is to combine human intelligence with AI. That's where you're going to create the most value, by combining the two together. The most effective business solutions combine both human and artificial intelligence, leveraging strengths of both. Now let's move from AI to some of the specific applications and explore how AI learns from data. Machine learning learns from examples, not hard-coded rules. Some of the use cases, like customer segmentation, fraud flags, demand forecast recommendations. Think show then tell. Imagine where you provided a data set of insurance fraudulent claims, a data set of not fraudulent claims, and then you ask the algorithm to understand, compare and contrast the two to be able to confidently pick fraudulent claims. That's example of machine learning in action, and it's been used for a very long time. Stop for a second and think about a repetitive task in your business that involves making decisions based on patterns. How could machine learning help? Some of the things to consider: do you already have a data that's called label? Do you have a data where something has been already successful? Think, for example, successful sales versus unsuccessful sales. What kind of quotes, proposals secured your deal versus that don't? If you have that data and it's been historically aggregated for a little while, these are going to be perfect data sets for machine learning, as you will be able to use algorithms to contrast and compare and assist with decisioning. Now, deep learning is a form of machine learning with many layered neural networks. Great with understanding data, images, text, audio. It auto-extracts features, but need a big data and big compute to be leveraged. This is why you have Google, Microsoft, OpenAI, and the others leveraging deep learning. For many small to medium-sized organizations, deep learning is outside of the reach because of the costs involved to prepare the data sets to make the deep learning work. That is nevertheless the keystone for the foundation models that those large organizations produce. And we all get to benefit from that by having access to the foundation models. Let's talk about some of the examples. Image recognition for quality control. Imagine your business training on lots of photos about what is a cat or what is a chair. Now, that's not necessary anymore because that deep learning has been done on the publicly available data, and you can now benefit by having access to the algorithms that already been pre-trained. Same for the natural language processing. If you operate a call center, imagine the ability to transcribe every single call as it comes in. That is again example of applied deep learning that you didn't necessarily need to do yourself within the business. You just get access to the algorithms. Deep learning able to uncover structured patterns in inherently messy and unstructured data. Another way to think about the business impact of deep learning, that it enables the automation of tasks that previously required human perception, like a document processing or visual inspections. And last but not least, let's talk about the creative revolution in AI, or how GenAI revolutionized business. GenAI produces new text, images, audio, video, and code. It learns patterns and recombines them into something new. Impact: you can have a contents in minutes, prototypes at the tenth of the cost, faster than the dev cycles before. There is no doubt you already seen some of the products like Nana Banana from Google, which allows to achieve something closer to a Photoshop fidelity by combining 2 or 3 images in a single prompt. That can revolutionize part of your marketing and part of your web design or others, where before you needed to work with the stock images and pay expensive Photoshop experts, where now you can get to what you want or close to that with the minimal human touches with just a single prompt away. It doesn't stop there. GenAI can also generate code that accelerates your development cycles or helps you to spot bugs in the software before it being deployed. Now, large language models are built on the back of neural nets, machine learning, deep learning, and GenAI. It's the combination of all of those technologies together that allow us to produce now large language models. They predict the next word really well, enough for us to think that it's a fluent human speech. It's transformative for where the language needs to be used. Would that be customer service or content creation or research that condenses days of work into minutes? Large language models are also exceptionally good at translating text, and their accuracy is phenomenally high, and they only get better every day. Think of LLMs as a prediction engine for text. This is your next word predictor on steroids. It is the invention of LLMs that transformed the field of AI with advent of ChatGPT. LLMs, they can understand the context and nuance in the ways that previous AI couldn't. And we're going to touch on some of that technology and why that is the case. LLMs enable more human-computer interaction in the field of natural language processing. What I mean by that, you can speak to the computer, you can type a prompt, it will understand what you mean with the power of LLMs. When I deliver this content, a typical point of confusion is the difference between AI and automation. Let's talk about that. Artificial intelligence are the systems that can perform tasks that typically require human intelligence, like a digital brain that can learn and adapt. Machine learning is a subset of AI systems that learn from data without explicit programming. And automation is a separate set of technology that's used to perform tasks with a minimal human intervention. I think you can see where I'm going, how it is being combined. Automation, think it's like a dishwasher versus washing dishes by hand. If you think about your business, simple rules-based tasks, they lend themselves to traditional automation really well, and you often don't need artificial intelligence. Complex tasks that require judgment and decision, these often involve AI-powered solutions for their automation. Let's briefly stop for a second and talk about a workflow. A workflow is a set of steps with triggers, actions, and decisions. It connects people, systems, and data. There's no doubt you already have workflow within your business right now. These can be defined as processes or perhaps learned by people as they're doing their jobs. Now, every single workflow will have a trigger, usually some type of a decision, and often actions. Now, when it comes to automation of the workflows, this can be done with AI or without AI. Now that we covered the foundation terms about AI and machine learning, let's talk about how to go from tools to teammates. An AI agent can plan steps. So if you remember, it can use reasoning, it can use tools, and can iterate with the feedback. It designs its own mini workflow to hit a goal. If you think about human intelligence, and let's say your sales agent that's working for your business, that's not different. That sales agent can also plan steps, use tools, and iterate with the feedback, and also plan its own workflow. When your sales agent walks in the office in the morning, he plans his day, he plans how he's going to tackle next opportunity, prioritizes to work, learns from the past experience, and goes about his day. AI agent is no different from the point of view of the tools and capabilities. The only difference is in technology. Think about AI agents in the current phase like junior employees, that every day for them is a new day. They have a tremendously good memory, but that memory is often short-lived. They know how to interact with tools, but every time they interact with tools, they learn about those tools. Another term that often causes a lot of confusion, and that's agentic AI. Agentic AI changes tasks, calls, and APIs. Agentic AI is that LLM, that AI model that we talked about, that represents as a LLM, that is able to interact with tools. So not all LLMs out there, not all providers out there, able to produce their foundation models in such a way that they can be embodied as agents. When those models are trained in a specific way and equipped with additional capabilities to be able to call on tools, do reasoning, chain tasks, that's when they are called agentic AI. Now, we've talked about that AI often like a junior employee, and no doubt as a business leader, you know what kind of communication skills it requires when you have a new junior employee that requires onboarding. AI is no different. Communication with AI is a key to success. Let's talk about that now. The first term that we will touch on is context. Context is the model's working memory. Your initial prompt, that question that you ask, chat history, retrieved documents that you might have loaded. It's all bounded by a context length and often referred to as a context window. That bigger window costs more, but you need to manage the context well because that will allow you to save money and also will allow you to get better and more accurate answers from your AI. Tokens are chunks of text, roughly 3/4 of a word in English. You pay per token. And that means more tokens used, more costs, and often slower responses. Here's an example. AI Foundation Workshop made out of 5 tokens. AI, Found, Asians, Work, and Shop. Use a tokenizer site, there are multiple online, to see how text splits in various tokens. What you will notice that the different models split tokens differently and work with them different. Now, no doubt you already know what is a prompt, but let me repeat myself. A prompt is your instruction. Usually it includes a goal, audience, tone, constraints, and examples. Better prompts lead to better outputs, fewer retries, and usually the lower cost for your business, and much higher accuracy and a chance of meeting your goal. Now, that's a point to your side, but it's important that you understand. This is the big picture. Don't memorize it. Just know attention is the engine for how large language models work. Look at example 1. The animal didn't cross the street because it was too tired. Now, you know it refers in that sentence to the animal. Let's read another example. The animal didn't cross the street because it was too wide. You could see with a slight change in the last couple words, you as a human know that it refers to the street because it was the street too wide, not the animal. The attention mechanisms help understand these relationships by focusing on a relevant context. It is this insight, which I believe was based on a Google paper, that allowed us to create LLMs. Each model, each foundation model has a training end date. Anything after that is unknown to it unless you provide it or it will be allowed to use one of those tools to browse the internet. Let's have a look at an example. Various models have different cutoffs. Always check which model you're using and when the training finished. Even if the model was released recently, it still doesn't mean that the cutoff is recent. Look at some of the examples on the screen. Llama 4 was released in April 2024, but the cutoff is August 2024. Why does that matter? That matters because you take a latest model like ChatGPT 4.5 and you ask it, do not search online when Donald Trump was elected. And it will be convinced that the Donald Trump was elected only once and never again, because it simply wasn't aware of another election after. Now that you learned about AI, agents, and different attributes, how do you customize AI for your business? We'll talk about the training in a minute, but the large foundation models, those LLMs, they've been created on a publicly available data. But of course, your business has its own data, and not all of it is available online for those models to train on. So naturally, you would want to, in some cases, take the model and improve it or augment it with your own data. That is called the fine-tuning. Fine-tuning typically pays for itself because you augment the large language models with your own data from your own systems, which then means that the models become aware of your data. But of course, that has to be done every time and usually costs a fair amount of money. The impact of fine-tuning, though, is great because it can reduce your prompts, as model will be already aware of a lot of your data, and it can significantly increase the accuracy for the specialized tasks relevant to your industry and your business. Think of it what it takes to onboard a junior employee into your business and how long it takes them to become proficient and understand your systems, data, processes, what is it that you sell. Now, embeddings is another counterintuitive word. It means convert the content into vectors or numerical fingerprints. They power the search and the recommendations. Now, it's great for clustering feedback and finding related documents and the products, but that's also great for large language models to recommend the next word. Because if you remember, it's a predictive machine that predicts the next word. You use embeddings to take your internal data within the business and expose it not as text, but as embedding to your large language model of choice as a part of the fine-tuning. Now, we talked about embeddings and fine-tuning, how to take LLM and embed that information and knowledge into it, but it's often not the best way. In some cases, you would want to connect near real data or make a tool that would allow the agent to go and retrieve information. That's called retrieval augmented generation, when the large language models, through its ability to call tools, chooses for itself to go and call on that tool. One of the popular examples, your AI agent has access to your CRM. And when you ask it a prompt about a particular customer, it doesn't have each customer embedded into its memory. It simply chooses to go and call on the CRM to retrieve that information from there and then answer a query. It has lots of great benefits. It grounds your AI responses into your actual company data. We will talk about hallucinations in a minute, but this approach also reduces your hallucinations greatly. And you're only paying for the tokens that are used for the RUG compared to the fine-tuning or other methods where you have to pay for all of the data fine-tuned ahead of time. Can you stop for a second? If you thought about a particular business process that can be automated, could you think about what kind of systems that particular employee or AI agent would need to use? Can you think about how a RUG can be created for those systems, how data from those systems can be exposed to the AI agents? Okay, so everyone heard about the prompt engineering, but what is it? It's the craft of designing prompts, tests, and guardrails. It usually comes as reusable templates, and it lowers the cost and raises the quality of your interaction with AI. Prompt engineering is similar to context engineering, and that's how you ensure that your AI has access to all information it needs to execute reliably on the prompt. Let's talk about an example. A bad example would be write me a sales email. That's going to be very generic. A good example would be write a sales email for our new HR software targeting financial services companies with 500 plus employees. Highlight the compliance benefits and ROI, keep it under 200 words with a clear CTA in the end. That's okay, but could still be better. Then you could still use your RUG, connect to the CRM system, where then AI can write each email for each customer bespoke to their needs, to their industry, and highlighting the features that are specific to your software for their particular requirements. Last but not least, let's talk about some of the AI limitations and risks. One of the common challenges of using LLMs is the hallucination, and that's because they simply make things up. They confidently provide incorrect information, non-existing references or sources. It often completely fabricates details and statistics. Here's one example. The Smith-Johnson Act of 2019 requires all businesses to report AI usage. While that sounds perfectly confident and accurate, it's nevertheless completely false. AI is like that. It often tries to gaslight. It often tries to convince you with the full confidence and reasons and logic. Remember that example of 9.11 bigger than 9.9? That creates risk for your business. Any unverified AI output that's used for decision making can lead to compliance issues, wasted resources, and reputational damage. One way to overcome that is to make sure that the AI is always grounded in the data, has a human in the loop verifying and checking it, especially for the critical processes. And in some cases, you can connect multiple LLMs when one supervises the other, drastically reduce the chances of hallucinations. What is a vector? Vector is numerical representation of texts, images, or other data. It's simply mathematical values that capture meaning and relationships. Large language models, if you remember, we talked about tokenization, doesn't work with actual raw words. Each word is represented as a vector. Now, the vectors that your model has access to will directly impact on the quality of the output, as it simply tries to predict the next most probable vector. Vectors and vector databases is what you will need to use internally to make sure your knowledge retrieval from a company documents is stored securely and accessed securely. Vector databases will empower the semantic search for your systems and will ensure that the answer of your models is accurate. Think of vectors as a GPS coordinates for your content. They help AI to find related information in your business data. Vectors enable smarter document search, customer insights, and automated workflows. So I've talked about training the models. Let's unpack it a little bit more. You can see on the image representation here, there's a robot that's making up the soup. You put all the ingredients together and that soup is made and made for once. That's the essence of the large language models, foundation models, when they're being prepared by OpenAI on Anthropic. They spend months of cooking that large language model by carefully selecting the data, testing it, calibrating it, and going through millions and millions of iterations of billions of parameters to create that foundation model. Once the training of the model has been done, there's not much can be done to change and augment it except the fine-tuning or managing the context that it works with. Now that you understand what is the training, how that come to be, it's important another word that often confusing people, and that is what is inference. Inference is using the trained model that you saw on the previous slide to generate outputs. Like on this image, where this robot is now serving the customers of that soup that has been made. Once soup is made, there is not much you can do to adjust except add some spices and salt. And so is with the large language models. Once that's been prepared, you can change and augment it a little bit with additional context, with additional fine-tuning, but it can't be changed on a fundamental level. So business analogy, training is like educating an employee for years, while inference is like asking that employee to perform a task. Imagine you take a junior employee, you train them, you send them the training how to write good sales email. Now that junior employee has its brain, which is a form of neural network, and when it comes back from that training, he sits down and writes a better sales copy. That junior employee doing inference. It's exactly the same with the large language models. Another term to keep in mind is that there are multiple levers that you can pull when you're working with AI model. One of the common one that I would like to cover here, and that's because it's important, is temperature. Temperature adjusts how creative versus predictable the responses are from your large language model. You would lower the setting when you would like to get more focused and factual responses from your large language model, and you will put the temperature up when you're looking for more creative, varied outputs. Think about the difference between the marketing copy versus a support ticket. A couple key takeaways to summarize it all together. AI is the broad field. LLMs are just one type of AI technology, and you need to select the right AI technology for your purpose. It's the right tool for the right job approach. AI agents in the current phase are like junior employees. They need a clear guidance to be effective, but the business impact is that you can automate routine tasks at scale. Those junior employees now available at a really low cost. But nevertheless, just like you wouldn't want your AI employee that is junior to run your business, you wouldn't want the agent to run the business yet. It still requires senior supervision or human in the loop. Now the workflows, that's what connects it all together. That's what connects your internal data to the external data, to searches, capabilities, additional tools. Just like, again, your internal employees, they follow your business processes and the workflows. They have access to the systems. They have access controls within that system. So what they're allowed to do, what they're allowed to see, what they're allowed to perform, in what order. There's no difference. To get the value out of AIs, you need to think about the workflows, you need to think about the steps, you need to think about what it's allowed to access and in what order. Now, AIs are far from perfect. You need to verify AI information. Again, let's draw a parallel with a junior employee. When you have a junior employee, you're likely to pair him up with someone else who double checks at least on some of the work that junior employee does. With AI is no different at this time. You do need to choose your platform and technology carefully because different models from Anthropic, Google, or anyone else, they will work different because they've been trained different. There's different philosophy, different principles applied to it. So you need to choose your technology and the model appropriately for the right task. You need to test and validate. Now think about all of these concepts. How does it apply to your business? Do you see some of the low-hanging fruit, some tasks that easy to automate, and perhaps now with the advent of LLMs and ChatGPT, they can be automated at scale? I would appreciate your feedback. If you could pop in a comment one AI concept that you found the most interesting, and perhaps if you have any AI questions about the AI terminology I shared with you. This is the first video out of the series. In the next video, we will talk about AI landscape overview, where we will talk about various tools, platforms, AWS, Microsoft, Azure, Google, and others, and we will contrast and compare pros and cons of using different tools for your specific business needs. If you enjoyed this video, check others related over here. I will update these links as the next episode comes out. Please like and subscribe not to miss the next episode, and I'll see you in the next one.